Most people think every planet must orbit a star. But the universe doesn't care about what seems obvious. It has created billions of worlds that travel through the darkness completely alone. If that sounds impossible, stay with me. Because these rogue planets are forcing us to rethink how planets are born, how solar systems evolve, and what we really know about our place in the cosmos. By the end of this video, you'll see that some of the strangest objects in the universe aren't black holes or galaxies. They're entire worlds wandering through space with no sun, no home, and no destination. Imagine you're standing outside on a clear night. You look up and see the stars scattered across the sky. For as long as people have watched the heavens, there's been a simple assumption hiding in the back of our minds. A star is the center of a system, and planets move around it. That's how it works. The Earth goes around the sun. The other planets go around the sun. We discover distant worlds around distant stars. Everywhere we look, planets seem to belong to stars. But what if I told you that the universe has a habit of ignoring our expectations? What if there are worlds out there that belong to no star at all? Not a few, not hundreds, not even millions, billions. Entire planets wandering through the darkness of space with no sunrise, no sunset, no warm star lighting their skies. Worlds that travel alone through the galaxy, disconnected from any solar system. At first glance, that sounds impossible. After all, how can a planet exist without a star? Isn't a star the very thing that gives a planet its identity? To understand why these lonely worlds exist, we need to start with a simple question. How does a solar system form in the first place? A star begins as a giant cloud of gas and dust. Gravity slowly pulls this material together until the sun becomes dense and hot enough to ignite nuclear fusion. A star is born. Around that newborn star remains a spinning disk of leftover material. Tiny grains collide and stick together. Small rocks become larger rocks. Larger rocks become planetesimals. These become worlds. Given enough time, an entire planetary system emerges. Now, if nature always followed this neat story, every planet would remain safely attached to its parent star forever. But nature is not neat. Nature is messy. And gravity, despite being one of the most elegant forces in the universe, can create extraordinary chaos. Imagine several giant planets forming within a young solar system. Each one exerts its own gravitational pull. They tug on one another continuously. Most of the time, these interactions are gentle, but occasionally they become violent. Think of children spinning around on a playground carousel. If everyone remains balanced, the ride continues smoothly. But if one child suddenly shifts position, the balance changes. Movements become unpredictable. Something similar can happen among planets. In the crowded early years of a solar system, planets can migrate inward or outward. They can cross paths. They can enter gravitational encounters so powerful that one planet receives a tremendous kick. And that kick can be enough to throw an entire world out of its solar system forever. One moment it is orbiting its star. The next moment it is escaping into interstellar space. No return ticket, no second chance. Gravity, the same force that built the planet's home, becomes the force that destroys it. This process may sound rare, but the universe is very large, and it has had a very long time to conduct experiments. If even a small fraction of planetary systems eject planets, the numbers become astonishing. There are hundreds of billions of stars in our galaxy alone. Many stars possess planetary systems. If countless systems have experienced gravitational upheaval over billions of years, then enormous populations of rogue planets should exist. And increasingly, observations suggest they do. Now think about how difficult these objects are to find. A planet normally reveals itself because a nearby star illuminates it. We detect the star's light. We notice tiny changes in that light caused by the planet. But a rogue planet has no nearby star. It's like searching for a black pebble floating through a dark ocean at midnight. How do you find something that emits almost no light? Astronomers had to become detectives. Instead of looking directly for the planets themselves, they searched for the effects these planets have on light passing behind them. According to Einstein's theory of gravity, massive objects bend space itself. When a rogue planet drifts between Earth and a distant star, its gravity can briefly focus the star's light. The star appears brighter for a short time. Then the planet moves on. The event may last only hours or days. Yet from that tiny flash, astronomers can infer the presence of an otherwise invisible world. It's a remarkable idea. You never actually see the planet clearly. You see gravity announcing its existence. It's almost as if the planet whispers, "I'm here," and then vanishes back into the darkness. The more researchers looked, the more evidence accumulated that these wandering worlds are not odd exceptions. They may be incredibly common. And that raises an even deeper question. What are these planets actually like? Imagine standing on one. There is no bright sun hanging in the sky, no blue daytime, no warm sunlight on your face, no seasons driven by a nearby star. The sky would be overwhelmingly dark. Stars would still be visible, of course, perhaps more visible than we have ever seen from Earth. But they would remain distant points of light, offering beauty but no warmth. Temperatures on many rogue planets would plunge to unimaginable levels. Their surfaces could be frozen solid. Oceans might become vast sheets of ice. Atmospheres could collapse and freeze onto the ground. Everything sounds dead. Everything sounds impossible. Yet this is where the universe becomes truly fascinating. Because life, as strange as it sounds, may not require sunlight as much as we once believed. Here on Earth, we naturally associate life with the sun. Plants capture sunlight. Ecosystems depend on that energy. But there are places on our planet where life thrives without any direct sunlight at all. Deep beneath the ocean, near hydrothermal vents, entire communities of organisms survive using chemical energy emerging from Earth's interior. They do not care whether the sun is shining above. Some never encounter sunlight in their entire existence. This discovery changed the way scientists think about habitability. Perhaps warmth from a star is not the only path. Consider a rogue planet larger than Earth. Inside it, radioactive elements continue to decay. The planet's interior remains warm. Geological activity generates heat. Now imagine a thick atmosphere acting like a giant insulating blanket. That atmosphere could trap enough heat to prevent all liquid water from freezing. Beneath an icy surface, hidden oceans might survive. Dark oceans, warm oceans, protected oceans. Could life emerge there? Could it persist for millions or billions of years? Nobody knows. And that uncertainty is exciting. Science is often portrayed as a collection of answers. In reality, science is a collection of increasingly interesting questions. The moment we discover something unexpected, the universe hands us a new mystery. Rogue planets are exactly that kind of mystery. They force us to question assumptions we didn't even realize we were making. For example, we tend to think of planetary systems as stable families, a star in the middle, planets moving peacefully around it. But the existence of rogue planets reveals a more dramatic picture. Solar systems can be violent places, worlds can be expelled, orbits can change. Planetary histories can involve catastrophe. The universe is not a perfectly organized machine. It is a dynamic, evolving system filled with collisions, migrations, disruptions, and surprises. And perhaps the strangest realization is this: our own solar system may not be entirely innocent. Long before humans existed, long before Earth developed life, the giant planets were moving through different positions. Jupiter and Saturn influenced the architecture of the solar system profoundly. The early solar system was a gravitational dance. Some objects survived, others did not. It is entirely possible that worlds once existed here and were eventually lost. Imagine that for a moment. There may have been planets associated with our sun billions of years ago that no longer belong to it. Planets that were cast away into the galaxy before Earth had even formed complex life. If so, they are still out there somewhere, traveling endlessly through the darkness. This idea changes how we think about planets themselves. A planet is not merely an object orbiting a star. A planet can have its own story, its own journey, its own destiny. Some worlds remain close to their suns for billions of years. Others become cosmic wanderers. They travel between stars, crossing distances so enormous that human language struggles to describe them. The galaxy is often compared to a city of stars. If that's true, rogue planets are the drifters moving through the empty roads between neighborhoods, silent travelers passing through regions where no sun shines. And there may be far more of them than we once imagined. Think about the scale involved. The Milky Way contains hundreds of billions of stars. Now imagine that rogue planets are equally numerous, or perhaps even more numerous. Suddenly the galaxy becomes populated not only by stars and planetary systems, but by countless isolated worlds moving independently through space. The image is breathtaking. Instead of islands around stars, the galaxy may be filled with an enormous hidden population of unattached planets. A vast invisible frontier. And this is one of the most important lessons the universe teaches us again and again. Reality is usually stranger than our first guess. Whenever we become too confident that we understand how things work, nature reveals another layer. We thought planets belonged to stars. Then we found planets wandering alone. We thought sunlight was essential for every possible ecosystem. Then we discovered life thriving without it. We thought empty space between stars was relatively simple. Then we realized it may contain billions of unseen worlds. Every answer opens another door. Every discovery expands our ignorance. And that is not a weakness. That is the beauty of science. The goal is not to arrive at certainty and stop asking questions. The goal is to keep discovering better questions. So the next time you look up at the night sky, remember something extraordinary. The stars you see are only part of the story. Between them may drift countless worlds hidden from view. Frozen worlds. Dark worlds. Perhaps even living worlds. Planets with no sun. Planets with no home. Planets that have spent billions of years crossing the galaxy alone. And somewhere in that immense darkness, beyond the reach of our eyes, one of those silent travelers may be passing through space right now, carrying with it secrets about planetary formation, gravity, life, and the true complexity of the cosmos. The universe is not only larger than we imagine, it is often far stranger than we imagine. And among its strangest creations are these lonely wanderers, billions of planets moving through the darkness, untethered to any star, reminding us that reality is far more astonishing than anything we would have invented on our own. Now, once you begin thinking about these wandering worlds, another fascinating question appears almost immediately. If a planet can survive without a star, Then what exactly defines a planetary system? We often think of planets as secondary objects. The star gets all the attention. The star provides the light, the heat, the energy. The planets seem like supporting actors in a much larger story. But rogue planets force us to reverse our perspective. Imagine removing the star entirely and focusing only on the planet. What remains? A world with geology, a world with gravity, a world with an atmosphere, perhaps, a world with a history stretching across billions of years. In other words, the planet remains a complete physical system all by itself. This is an important shift in thinking, because it reminds us that planets are not merely decorations orbiting stars. They are worlds. Each one is a unique experiment conducted by nature. Some have mountains taller than anything on Earth. Some have storms larger than entire continents. Some may possess oceans beneath frozen crusts. Some may be covered entirely by ice. Some may be rich in exotic chemicals we have never encountered. And some may be traveling through space completely alone. The moment we accept this idea, the number of potentially interesting places in the galaxy increases dramatically. For a long time, when astronomers searched for habitable environments, they focused primarily on the so-called habitable zone around stars. This is the region where temperatures may allow liquid water to exist on a planet's surface. It's a useful concept. But nature has a habit of refusing to stay inside our categories. Because once you discover worlds that can maintain internal heat, worlds that may trap warmth beneath thick atmospheres, worlds that could contain subsurface oceans, the traditional picture becomes incomplete. The universe starts presenting alternative possibilities. And whenever nature presents alternatives, scientists become interested. Not because the alternatives are necessarily correct, but because reality has already surprised us enough times that we can no longer afford to dismiss unusual ideas too quickly. Think about how many assumptions have already been overturned. There was a time when people believed Earth occupied the center of everything. Then we learned it orbits the sun. There was a time when we thought our galaxy contained the entire universe. Then we discovered billions of other galaxies. There was a time when planets outside our solar system were purely hypothetical. Today we know of thousands. And now we are discovering that even planets themselves may not need stars to exist as long-term travelers through the cosmos. Each discovery widens the boundaries of possibility. Now consider the journey of a rogue planet after it is ejected. Once it escapes its parent system, it enters a realm almost impossible to visualize. The distances between stars are enormous. Light itself, moving at nearly 300,000 kilometers per second, requires years to travel from one star to another. A rogue planet drifting through interstellar space may spend millions of years without passing anywhere near another star. Imagine that level of isolation. On Earth, isolation means being far from a city. On a rogue planet, isolation means being far from everything. No neighboring planets, no nearby sun, no familiar constellations remaining fixed in the sky. Just an endless voyage through darkness. Yet even darkness has structure. Interstellar space is not completely empty. Tiny particles drift between stars. Magnetic fields stretch across enormous distances. Cosmic rays race through the galaxy at incredible speeds. Clouds of gas slowly move and evolve. A rogue planet travels through this environment continuously, like a ship crossing an ocean so vast that its shores can barely be imagined. And because these journeys last billions of years, something extraordinary becomes possible. A rogue planet might not remain alone forever. Given enough time, gravity occasionally arranges unexpected encounters. A wandering planet could pass near another star. If conditions are exactly right, The star's gravity might capture it. The homeless world could become part of a completely new planetary system. Think about how remarkable that would be. A planet born around one star, expelled into interstellar space, wandering for hundreds of millions of years, and eventually adopted by another star entirely. Its history would be written across multiple solar systems. Its story would span regions of the galaxy separated by unimaginable distances. We often think of stars as permanent homes for planets. But perhaps, in rare cases, planets migrate between stellar families. The galaxy may be far more interconnected than it appears. And there is another possibility that sounds almost like science fiction, but emerges naturally from the laws of physics. Suppose a rogue planet carries microbial life beneath its surface. Suppose that life survives within protected underground oceans for immense periods of time. If the planet eventually enters a new stellar system, it may suddenly find itself receiving energy from a nearby star once again. Conditions could change dramatically. Frozen regions might thaw. New chemical reactions might begin. Environments that were dormant could become active. Life, if it existed, would encounter an entirely new chapter in its planetary history. Notice something important here. None of these ideas require magic. None require violations of physical law. They emerge simply from taking gravity seriously and allowing the universe enough time. Time is one of the most powerful ingredients in nature. Processes that seem impossible on human timescales become inevitable on cosmic timescales. A mountain can be eroded grain by grain. A continent can move thousands of kilometers. A star can be born, shine, and die. And a planet can be thrown into the darkness and wander across the galaxy. The universe is patient, far more patient than we are, because we experience decades, while the cosmos works comfortably with billions of years. This difference in perspective often hides important truths from us. When we look at a solar system, we tend to see stability because our lives are short. But if we could watch the same system for hundreds of millions of years, we might witness dramatic transformations. Orbits shifting, planets migrating, moons being captured, asteroids colliding, entire worlds being expelled. What appears permanent may simply be changing very slowly. This idea applies far beyond rogue planets. It is one of the deepest lessons in science. Many structures that seem fixed are actually processes. The Earth is changing. The sun is changing. The galaxy is changing. Everything is changing. The changes simply occur on timescales larger than our everyday experience. Rogue planets are evidence of that hidden dynamism. They are reminders that planetary systems evolve. They have histories. They have accidents. They have moments of stability and moments of chaos. And the consequences can be extraordinary. As astronomers build more powerful telescopes, the search for these worlds is becoming increasingly sophisticated. Future observatories may detect thousands of rogue planets directly. Some may reveal atmospheres. Some may reveal temperatures. Some may reveal chemical compositions. Each discovery will provide another clue about how planetary systems form and evolve. Because every rogue planet carries information about its past. If we can study enough of them, we may reconstruct the events that created them. It's similar to finding driftwood on a beach. The wood itself tells part of a story. Its shape reveals where it has been. Its condition reveals what it has experienced. In the same way, a rogue planet contains evidence of ancient gravitational events that occurred long before humanity existed. By studying these worlds, we are not merely counting planets. We are reading the history of the galaxy itself. And history, when written on cosmic scales, becomes astonishingly rich. Every wandering planet represents a narrative stretching across billions of years. A birth, a home, a disruption, an exile, a journey, and perhaps someday another destination. And perhaps that is the most profound lesson hidden within these lonely worlds. We began with a simple assumption. Every planet needs a star. It seemed obvious. It seemed unquestionable. Yet the universe revealed something entirely different. It showed us billions of worlds traveling through the darkness alone, existing perfectly well without the thing we thought they could never live without. Again and again, nature teaches the same lesson. Reality is not obligated to match our intuition. The universe is not strange because it is complicated. It is strange because it is far more imaginative than we are. Every time we think we have reached the edge of understanding, we discover another layer beneath it. Every mystery solved uncovers a deeper mystery waiting beyond. And that is why science is not a journey toward certainty, it is a journey toward ever greater wonder. So the next time you look up at the stars, remember that the greatest discoveries are often not the things we can see, but the things we never expected to exist. Somewhere in the vast darkness between those distant lights, billions of unseen worlds are drifting silently through space, carrying stories we have not yet heard and secrets we have not yet uncovered. And if billions of planets can exist where we once thought none could, then perhaps the most dangerous words in science are not "I don't know," but "I already know." Because the universe has spent 13.8 billion years proving that it is bigger, stranger, and more astonishing than our imagination. And the moment we stop being surprised by it is the moment we stop truly looking.